So here we are back again talking about sine and cosine. The last video we discussed 30, 60, 90 triangles, so now we're going to bring the 45, 45, 90 triangle. And just to remind you, if the hypotenuse is 1, then the legs are going to be the same, and they're going to be 1 over rad 2 and 1 over rad 2. So if I'm trying to find the cosine of, say, 45 degrees, then I go to the unit circle and I find where 45 degrees is in the unit circle. And when I draw that line, I notice that you can drop a straight line down to the x-axis, and that forms, because this is 45 degrees, that forms a 45, 45, 90 right triangle. And since, once again, this is a unit circle, so the hypotenuse is 1, and cosine is adjacent over a hypotenuse, that means it's going to be this side over 1. And of course we know from the triangle that that side is 1 over rad 2. And if we did another example, like cosine of 135 degrees, okay. Again, if we draw the unit circle, 135 degrees would be 45 past 90, so that would be right in the middle of the second quadrant. And again, this produces if I drop a line from the point down to the x-axis, it produces a 45, 45, 90 triangle. And another way to say that, it has a 45 degree reference angle. And so it draws us to that same triangle. And this time, again, the answer is going to be 1 over rad 2. But because we're looking for cosine, notice the adjacent side is going to the left of the y-axis, so that means it must be negative. So that would be a negative 1 over rad 2. And we could do the same thing with, for example, sine of 5 pi over 4. Okay. We know that pi over 4 is an eighth of the circle, because 2 pi divided by 8 equals pi over 4. So if we divide this into 8 pieces, it looks like this. So one of those pieces is pi over 4. So if I'm looking for 5 pi over 4, I'm going to go 1, 2, 3, 4, 5. So I'm looking right there. If I draw my line to the x-axis, I form a 45, 45, 45, 45, 90 triangle. And since I'm looking for sine, that's the opposite side. That's this guy over here. But of course, they're both 1 over rad 2. But since I'm in this quadrant, since I'm going down below the x-axis, that would make this a negative 1 over rad 2. So if we're doing multiples of 45 or pi over 4, notice the answer is always 1 over rad 2. It's just a matter of discovering whether it's negative or positive. Let's do one more example. If I want to know what cosine of 7 pi over 4. So I draw my circle, split it into 8 parts, and I count. Or actually, I could go here. I know that all the way around is 8 pi over 4, so that means 7 pi over 4 would be 1 back from that. So I'm sitting right here. There's my 45, 45, 90 triangle, and I'm looking for this length here on the x-axis, and that's going to the right, so that's a positive 1 over rad 2. Now let's put both of these together to get tan. Remember that tangent is equal to opposite over adjacent. So if I want to know what the tangent of, say, pi over 6 is, I can do the same thing I was doing before, draw my unit circle. Pi over 6 means I'm dividing it into 12 equal parts, which means I'll have 3 divisions or partitions in the first quadrant. So pi over 6 would be one of these. So there's my 30, 60, 90 triangle. And we know that this is 1/2, and this is rad 3 over 2. So tangent's looking for both of those. Tangent wants opposite, which is 1/2 on top, and adjacent, which is rad 3 on the bottom. Of course, if we, when you divide a fraction by a fraction, you can flip it over and multiply. So this ends up being 1 over rad 3. Let's do another example of tangent. So if I'm looking for tangent of 300 degrees, let's say, I draw my unit circle. And I know that this is 270, so 300 would just be 30 past that. So when I drop my line to the x-axis, notice I get a reference angle of 60 degrees. So this is a 30, 60, 90 right triangle, where the short side is here and the long side is there. And tangent is looking for both of those, so I want the opposite side, rad 3 over 2 on top, and the adjacent side, which is 1/2 on the bottom. And again, when I flip that over and multiply, I just get rad 3.